Hey everybody, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. Today I have with me Joe Goodwill. He is Assistant Professor of Civil and Environmental Engineering at the University of Rhode Island, and we're going to be talking about some of his research for the university, notably this paradigm of antifragility, which is born out of some other areas of research, but is being applied by him and his colleagues in the water and utility sphere. So we're going to hop right in just now. Joe, thank you so much for being here. We really appreciate you taking the time.
Sure thing, Bob. Thanks for having me.
So I wanted to talk. Let's start by kind of like getting an understanding of you and your research in the University of Rhode Island and kind of setting the stage for things. Could you talk a little bit about yourself, the university, and some of the work that you've been doing?
Yeah, so I'm an assistant professor in the Department of Civil and Environmental Engineering at the University of Rhode Island. We're the land grant institution in our state, so the big state school in our nation's smallest state. Actually, I think, a great combo. And we're I guess I'll use the word classic ABET accredited civil engineering program. So some of your readership that also attended a ABET accredited civil program, which many probably did, it'll seem really familiar. We have classes in fluid mechanics, physical chemical processes, biotechnology, and also transportation and structural engineering and the like. Yeah.
Hmm. Yeah. So one of the things that you've been working on is this concept of anti-fragility. We were talking before the call. You're saying that this isn't something that you created. It's something that you are
Yeah.
applying in a new context. Could you talk a little bit about what anti-fragility is and how you're working on it for the water industry?
Yeah. So the general concept, at least to my knowledge, was created by Nassim Taleb, who has had various positions, but amongst other positions, was a visiting professor at the University of Massachusetts when I was there getting a PhD. And he's written a couple of books that have made its way out of he was writing in the
Mm,
finance field, and some of the books I think became read more broadly, and including the title of Anti-Fragility and also Black Swan Events.
mhm,
And so this was, I'm probably going to butcher Nassim's work, but um, generally thinking from a financial perspective of how might a portfolio or an endeavor uh, gain in value when other things are not going so great. So
mhm,
you, at the very basic level, although anti-fragility really isn't this, you could think about it as a hedged portfolio or a diverse portfolio. So we have components, and I'm not a financial advisor, of course, but my understanding is that it's generally good practice to have two things that aren't perfectly correlated with each other, so that when one's doing well, maybe one isn't doing so well, but when the times change, you still have something that does well, right?
mhm.
And that's a way to begin to think about anti-fragility, and that was the way that I was introduced to it.
Yeah. So how does this compare or contrast with the concept of resilience, which we've heard a tremendous amount in the
Yeah.
past 2 years because of the pandemic, especially? But even like a year ago, the storm in Texas that created some real difficulties for water utilities and wastewater utilities down there, not to mention the electric grid. But um, could you talk a little bit about like how this differs from resilience or compares to resilience from a conceptual standpoint?
Yeah. So I think resilience is very important, especially it's becoming increasingly important, but it does sometimes get confused with anti-fragility. So I
Hmm.
look at resilience as um, being tough, surviving. Those are kind of synonyms to resilience. So that means that when times get stressful or you experience a black swan event, like that Texas storm that you just mentioned, that you survive. It's
Hmm.
bend but don't break, right? Or maybe break, but then you quickly recover from that.
Hmm.
So that's what I think resilience is. Um, Anti-fragility is different. Um, so if you could think about the analogy, if I was going to ship you something that was quite fragile, like we could imagine a delicate mug or something, right? That's a very fragile thing, right? So I could package that very carefully. and pad it, or take newspaper and stuff it, and get a big box and put that kind of annoying stuff with the bubbles in there, right? And then I could ship it to you, and I would have a reasonable expectation that it wouldn't arrive broken.
Mhm.
That packaging effort could be thought of as resilience, right? But that's different than anti-fragility. Anti-fragility would be, I send you a mug that, if it gets shaken in shipment, actually is a better mug. So it's conceptually challenging, but it would be made of a material that gets harder when agitated, maybe, as an
Mhm.
example. So that's the general paradigm as I think it's best understood. Yeah, it's different than resilience. And I'll say, if we have enough time here, that I think just that is useful, right? So just
Mhm.
understanding that paradigm is useful to a water system designer, a water system operator, because it at least allows for important questions to be asked. So there is something beyond resilience, right?
Mhm.
And it's important to at least ask these questions, rather than just pursue resilience exclusively. A way I like to think of it is like, if, I don't know, in our field and other fields, you'll hear some version of stationarity is dead, right? Or the 100-year storm is the 50-year storm now, or whatever. And there's consultants that are putting the word, change into their proposals, and everyone's talking about an increasing rate of change.
Mhm.
If that's true, which I think it is, if change is increasing, then having an adversarial relationship with change is not a good posture, right?
Fair. Totally
Yeah.
fair.
And I
Yeah.
think resilience is always going to have that adversarial posture, right?
Mhm.
I'm packaging up the mug because I don't want it to break, right? But if you have a mug that somehow gets better when shaken, you're like, bring on the change, right? That's going to be great. Yeah. And
Yeah.
that's very different. Yeah.
Yeah. One of the things too just hearing you talk about this made me think too that in a lot of ways resilience oftentimes is a response to an
Yeah.
event. It is a like you're responding to things. You may set up a plan ahead of time, but it's still about responding in a resilient way. Whereas this sounds like it's a little more proactive of an approach. It's more on that design side of things where
Yeah.
through the design process of building a new system or building a new pipeline or whatever, you're thinking about the fragile points and how do we make them less fragile, essentially.
Absolutely. It's more proactive, I think. And another thing that the paradigm does is that it frees you from needing to be able to predict everything,
Mm-hmm.
right? It frees you from this need to predict the future. Um, yeah,
Which is really challenging.
yeah, it's really challenging. Yeah, and our models. I'm not a climate modeler, but what I understand from looking at that literature is that when you zoom in spatially and get to grids that are like the size of Rhode Island, right?
Mm-hmm.
Um, though the predictions don't do as well, right? Than when you're looking at like maybe at the continent level or something like that.
Mm-hmm.
Yeah. So our ability to predict stuff isn't that great.
Mm-hmm.
And certainly our ability to some black swan events or some phenomenon are just too crazy to predict. Like who would have predicted Texas going into a deep freeze?
Yeah.
That's right. I don't think maybe somebody did.
Mm-hmm.
I don't know. And there's causal opacity to some of these black swan events, right? So we can look at the Texas event and say, well, no one would have predicted that. That's a black swan, or that's a 1 in 100, right, year event. And sometimes what causes something is very complex. So an example I like to bring up with this is this the concept of lake recovery or lake browning that's occurring a little bit in the Northeast and in Northeast US and in Atlantic Canada. And these are surface water bodies, reservoirs that are seeing increases in algae that's attributable to reduced sulfur and nitric acid deposition from acid rain because of Clean Air Act amendments in the 1990s. So
Mm.
to be able to predict Lake Browning or lake recovery, especially if, in Canada, right, you would have had to you would have had to think about or be aware of unintended consequences of another nation, the United States, changing their air quality laws, right? And that's a jump that I think is, well, we don't teach students at URI to design water treatment plants considering air quality regulations of other countries, right?
Yeah, definitely.
Right.
But it's interesting though because when you really get down to the like again that zooming in and out type of thing, when you really get down to it, all water is connected though too. So
Yeah.
in some way you almost do need to kind of think about those things. But more to the point of like what you've been studying and researching and stuff, could you talk a little bit about what you've learned from the Providence Water Supply Board? I know that you did some review and whatnot there. Could you talk about that? What you learned, how that relates to this anti-fragility aspect of what we've been talking about?
Yeah. So we were doing some research, applied research with Providence Water prior to the COVID pandemic. And what we were looking at was trihalomethane formations in one of their water storage tanks in the distribution system. This was a local hotspot for them, and they had had some challenges meeting regulations. And we started to collect data, and then the world shut down. And that changed water use patterns across the world, but of course in Providence, where you've got a downtown area that people weren't commuting to. And so long story short, water age went up, and so did trihalomethanes, because they're produced as a function of time, amongst other things. And so it was creating this problem. And this, is another one of these black swan event, causal opacity things, a global novel virus pandemic, changing water ages. We wouldn't have predicted that. And so Providence Water, though, was in a great position for this, because what we were testing there was the effectiveness of an aeration system for stripping trihalomethanes. They're somewhat volatile, and you can mitigate them. And they had that installed in the tank, and so they could switch on this adjustment or recovery option, given the high water ages and higher THMs that they were experiencing as a result of the COVID pandemic. And that was an interesting example of, I think, resilience. So they're still recovering from something, they're seeing a problem and adjusting. But we can also think about, in general, the aerative stripping of trihalomethanes as being an antifragile process, because it runs based on Henry's law. And I know I'm a professor. I'm not going to give a review of Henry's law, but suffice it to say that when there's more trihalomethanes in the water, the stripping process is more effective, right? You can even think of it like as from a Lachattier point of view. So as the problem gets worse, your solution for it gets better, right? So we're more effective at stripping when the temperature goes up, when there's more trihalomethanes. And so that's the kind of thing that I think lends itself, well, you could call that more anti-fragile than resilient. Yeah.
Yeah. So you use these air strippers you talked about in this case. Are there other technologies that you see this probably being a beneficial use case for, and by applying this notion of anti-fragility to water utilities?
Like other technologies that water utilities might think
Yeah.
about?
Yeah.
Yeah, there are a couple. And I recently wrote a paper that I think gives some examples of these. Another example might be, well, in industry practice, it's commonly referred to as manganese green sand filtration, right? But these are literally manganese oxide coated media that
Mm-hmm.
then adsorb manganese and then regenerate themselves, regenerate the surface if there's chlorine around. That's another great example of an anti-fragile process. So as the manganese in the water, that's a contaminant or what a target thing you want to remove, as that absorbs to the green sand media or the manganese oxide media and is then converted to manganese oxides by free chlorine, that means you have more sites available than when you started. So the process is going to get better as the manganese concentrations go up within limits, but in general, we can think about that. And so that's great. So that means if you are a water utility that is invoking this manganese oxide coated media green sand process, and it's anti-fragile and you're removing more manganese if more comes in the door, then you no longer fear manganese. Not that you feared it, but you no longer worry about it, and you no longer are uh, kind of shackled to accurately predicting what the concentration of manganese in the door will be tomorrow or next year or a month from now, and that can be pretty freeing. So those are the advantages. Yeah, that's another technology, as at least as it compares to ozone or something else. If you were going to have a strong oxidant and try to oxidize your manganese,
Mm-hmm.
a different approach to green sand filtration, you would need to know that dose or the amount coming in so precisely all the time. Uh, so that's another technology. Yeah.
Yeah. So, last question here. What steps can utilities try to take to move towards this? Are there first steps that they can take toward this anti-fragility mindset? And what would you tell a utility that's looking at trying to implement this mindset a little bit into the things they do?
Yeah. Um, the first step that a utility can make is to just consider the concept. So, and I think that would be very helpful, right? Um, so acknowledging that there's something else besides resilience, and that pursuing anti-fragility might be a worthy goal, or at least a healthy exercise as you think about the longer term operation or maintenance of a facility.
Mm-hmm.
Um, one tool to do that might be the paper that my colleagues and I recently published. If I can do a plug, there is an open access version to that hosted on the URI website. So it's available to everybody. We do lay out some examples of what fragile looks like, what resilient looks like, and what anti-fragile looks like through the lens of water treatment and potable water utilities. So just asking the questions, I think, will help frame next steps. I don't think that it's possible to be anti-fragile to everything, right? So even in my example of the mug, I struggled to give you an example of a mug that would do better if shaken, right? So, I can't. It's difficult to imagine, right? Like the type of treatment option that would have done great during the Great Texas Freeze Out, right?
Mm-hmm.
But at least trying to think about it, or think about it on a process scale, like an individual process, would be helpful. Yeah.
Yeah. Or even, as we had mentioned before, in that design phase for these engineering firms, consultants, and
Yeah,
stuff like that, thinking about that in the process of doing this capital work for a utility can help set that mindset as well. So it's not just the utilities that can benefit here, it's also the engineering firms and the consulting firms.
absolutely. I think consultants would do well to include considerations of anti-fragility. Um, it would make the field, I think, better. Concrete is a relatively fragile thing, right? Once you pour it is what it is. So any sort of considerations that we can make longer term that might improve the anti-fragility of these systems is going to help out immensely, especially when we all kind of agree that the rate of change does seem to be increasing. If that's the case, I don't think you want to be resilient I think you want to thrive, and that is more of an anti-fragile thing.
Yeah. Well, thanks so much, Joe. I really appreciate you talking to you about this. I certainly learned a lot about it as well. For everyone who's watching, we will have links in our description below. So that plug that Joe made, we'll make sure to get that link down there so you
Okay.
can actually view it. And thanks so much again, Joe. And we'll reconvene with everyone next week for our next video.
Thank you for having me. Appreciate it.